Hello, people. This is Vikas Sharma, and I welcome you all on behalf of Exponent to Success to this another video of ours. And today's video talks about understanding the slope or gradient of a line. Now, how does one see what the gradient of a line is or what the slope of a line is? But before we actually head into the video, I wanted to discuss a few points with you. First of all, I'm going to discuss the coordinate system with you. So as you know that this is the coordinate graph that we have. This is also called a Cartesian plane, and it has two axes. One is the x-axis, which is the horizontal line that you see, and one is the y-axis, which is the vertical line. And the 0 point here that you see is called the origin. So this is where the line starts from, and the y-axis which goes up from the origin, it's positive numbers, and when it comes down from the origin, those are negative numbers. Similarly, on the x-axis, on the right hand side of the origin, they are all positive numbers, while on the left hand side they are all negative numbers. So every point has got a coordinate, and the coordinate the way we denote coordinates are, there are two numbers on it. One is the x coordinate and the other is the y coordinate. They are written in parentheses, and the x coordinate always comes first, then the y coordinate comes. So if we write for example 2 3, that means 2 is the coordinate on our x-axis and 3 is the coordinate on our y-axis. So how do we locate this point 2 3 on the Cartesian plane? Is you start from the origin. 2 is the x coordinate, so you go right and look for 2, and 3 is the y coordinate. So at the 2 line, the vertical line, where is 3 on the y-axis? It's right here. So this is our point 2 3. Now similarly, if we have to locate the point -4 2, so we have got -4 is on the x-axis is this side, on the left hand side, extreme left, and 2 on the y-axis at that is this point. So that's our point -4 2. Similarly, any point on the Cartesian plane can be given coordinates. For example, what is the coordinate of this point? So on this point, when we have to write the coordinates, we look at the x-axis first. So x-axis, it is at the number 3, and at that point the y-axis is on the number 1. So the coordinates of this point are 3 1. What are the coordinates of this point? So this point again on the x-axis, if you look first, so -2 is on the x-axis and -3 is on the y-axis. So the coordinates of this point are -2, -3. Now to find the gradient, gradient has a very simple formula. It's not complicated at all, and gradient, as I told you in the last videos also, it's also called the slope, and the formula is very simple. It's just the rise over run. So rise means how much is the line rising on the y-axis versus how much distance is it covering on the x-axis at the same time. So for example, we'll come to the gradient, and gradient has a formula also. So in case you find it difficult using the rise over run, you can just calculate it using the formula, which is y2 upon y1 over x2 minus x1. So this is assuming that we have 2 points on the line. Any 2 points on the line, the coordinates of the first point are x1 and y1, and the coordinates of the second point are x2 and y2. So we just take the y coordinate of the second point, subtract the y coordinate of the first point from that, and similarly divide that by the difference between the x coordinates of both the points. So that's the formula for calculating the gradient. Now As a few examples, I have taken some lines with me, and the objective is just to find the gradient of these lines now, and also the x and the y intercept. So looking at these points, I'll start with line number one. So line number one is this black vertical line that you see here, and the gradient of line number one will be rise over run. So we'll how much is the line rising? Well, it continues to rise at the same point, and versus how much distance does it travel. So let's say for every 1 unit on the x-axis, how much does the line travel, how much does the line rise. So we look here that if we go on the x-axis, it's not moving towards the right at all, so it's not it's difficult to calculate the run. So let's find out the gradient using the formula that we have. So let's locate any 2 points on the, let's now what are the coordinates of this point? So this point is 4 on the x-axis and 6 on the y-axis. So 4 and 6, and let me take any other coordinate, say how about this one? So the coordinates of this point are 4 on the x-axis and 2 on the y-axis. So gradient would be equal to y2 minus y1. So if this is our first point and this is our second point, or if this is our first point and this is our second point, then the gradient is 6 minus 2, or I could have also taken 2 minus 6. It doesn't matter which point you take as the first or which point you take as the second, it will ultimately come out to be the same thing. And the difference between the x coordinates at the 2 points, so it's 4 minus 4, so which is 6 minus 2 gives you 4, and 4 minus 4 gives you 0. Now 4 divided by 0, that is actually not defined, because division by 0 is not possible. So the gradient of this line, gradient of a vertical line, is not possible. There is no y-intercept for this line, because this line will continue to rise at this point only. It is never going to touch the y-axis, and if we go down also, it will continue to be parallel to the y-axis. So there is no y-intercept for this point. The x-intercept, of course, if you look at the x-intercept, so it's intercepting the x-axis at the point 4. So x-intercept we can write 4. Now let's come to the second point, which the second line, which is the vertical line here, the blue colored line. So the gradient for this line, again if we look for the rise, the line is not rising at all, and while it's traveling horizontally along the x-axis or parallel to the x-axis, so it's continuing to go in one direction or both the directions, but it's not rising at all. So gradient rise, since rise is 0, so the gradient should be 0 anyways. If we take 2 points of reference, say this point and this point, so the coordinates of this point are 6 on the x-axis and negative 2 on the y-axis, and the coordinates of this point are negative 4 on the x-axis and negative 2 on the y-axis. So the gradient obviously would be negative 2 minus negative 2, which are the two y coordinates, upon 6 minus minus 4. So that gives us minus 2 plus 2 upon 6 plus 4, or 0 over 10. So the gradient of this line is 0. The x-intercept, there is no x-intercept because the line continues to be parallel to the x-axis. The y-intercept, of course, is negative 2. So we can write the y-intercept is negative 2. The gradient of the third line, which is the red line over here that you see, the upward sloping red line, let's find out the gradient of that. So gradient again is rise over run. Let's see how much is this line rising for every 1 unit of x. So first of all, we'll have to locate some points which are easily identifiable. So how about taking this point as one, and the second, where is, I can take this point, because these 2 points are right on the grid, so it's easier to mark them. So I can say if this point is 6 on the x-axis and 2 on the y-axis, and this point would be negative 6 on the x-axis and negative 8 on the y-axis. So I can take any, so if this is my point 1 and this is my point 2, so y2 minus y1, so I take 2 minus negative 8 over the x coordinate of the second point is 6 minus negative 6, or I can say 2 plus 8 over 6 plus 6, which is 10 over 12, or in simplest terms that would be 5 over 6. That means for a run of 6 on the x-axis, the line is rising by 5 units. So that is going to be my gradient. So we can verify it on the graph also. So for 6 units on the x-axis, so that brings us to the y-axis from this point, and it rises 5 units up. So there we see that's our point. So from this point it is rising 5 units, and of course if we have to find out the x-intercept and the y-intercept, so the x-intercept would be x-intercept is where it is cutting the x-axis. So here you can see it is intercepting the x-axis here, so which is slightly more than 3, so difficult to say what it is. So it's 3 point something, and y-intercept of course is very clear, it's negative 3. So that's the y-intercept. Now I would like to leave you for with the other 3 lines, the 4, 5 and 6, and you can pause the video here and try and work out the gradient yourself. Meanwhile I'll come back with the solutions. So there, my friends, are the solutions. So if you look at the line 4, I've taken 2 points of reference on the line, which is the green line over here. So I've taken the points of reference as negative 4, negative 10 right at the bottom, and I've got 0, 0 at the origin. So if we find out the gradient, we found it out to be 5 over 2. That means for every run of 2 units on the x-axis, the line rises by 5 units on the y-axis. The x-intercept is 0, y-intercept is 0, so it's going through the origin. That means 0, 0 are the coordinates of the points. And if we look at the gradient of line 5, which is the downward sloping line in blue color, so downward sloping lines, as I told you in the last video, they always have a negative gradient. So again I've taken 2 points of references, so one is negative 6 and 4 on the as one point, and negative 2 and 0 as the other point. So the gradient we have worked out as negative 1, and if we look at the x-axis, so it is intersecting the x-axis at the point negative 2, 0, and it is intercepting the y-axis at the point 0, negative 2. So the gradient for the 6th line, or the green colored line, I've taken 2 points of references as negative 4 and 8, and the other point was 0 and 2. So if we look at the gradient came out to be negative 3 over 2. That means for every run of 2 units on the x-axis, the line has fallen by 3 units on the y-axis. So this is again a negative gradient. The x-intercept where it intersects the x-axis is a little over 1. So if this is 1, so I've taken it as 1.5 or 3 over 2, and y coordinate at that point is 0, and y-intercept is the point 0, 2. So do you notice that whenever we find the x coordinate or the x-intercept, the y-intercept is 0. Here also it was 0, and x coordinate, x-intercept, here also y coordinate was 0, and when we find the y-intercept, the x coordinate is 0 in both the cases. So that's one thing to remember, that at the x-intercept y coordinate is 0, and at the y-intercept x coordinate is 0. So that was all about working out the gradients of the line. So once we have the graph and we can identify 2 points which are right on the grid, the gradients become quite easy to calculate and to verify. You can obviously see if it's an upward sloping line, it will be a positive gradient, and if it's a downward sloping line, it's going to be a negative gradient. A horizontal line always have a gradient of 0, and a vertical line has no gradient if the gradient is not defined in that case. So those are some few points to remember about gradients. So friends, if you really like the video and you're looking forward to learn something new out of this video series, then I must suggest that you should subscribe to the channel. So look for the subscribe button right under the video and click on the subscribe button, and whenever a new video is put out or posted, it will come right into your inbox, so you will never miss another video of ours. And in case you're learning something beneficial out of it and you wanted to share the same with your friends, ask your friends to come to this to look for this channel on YouTube. Let them also subscribe to it and get the full benefit out of it. And I'll be happy to answer questions for you, and please leave your comments in the comment section below in case you have any questions, or if you are facing any problems and you want me to help you with that, so I can make a video series on that also. So just send me your problems in the comment section, and I'll be sure to make a video on it. So please friends, like, subscribe and share the video. God bless you. Study hard.